So, hey, welcome. This is Anatomy of a Click. A little bit about me. I work at this place called Testim, which is really cool, and I do a bunch of open source. When I give this slide, people look at it and they say, yeah, it's impressive, you work on stuff like Node, but I wanted to say that any of you can work on stuff like Node or like MobX. MobX is like this really popular JavaScript library. There is literally an open issue right now. Hey, we are looking for maintainers. We will help you and train you and like show you around the source. So if any of you want to get into open source, really good opportunity right now. Awesome. And this is my wife and my dog Bimper dressed like a bee. Great. I want to say that it's not necessary to know any framework internals to be a good developer. And to be a good React developer. If you are not intimately familiar with the way events work in JavaScript or in the DOM, you shouldn't feel bad. That's the point of abstractions. If you had to know every detail, then the abstraction would be completely broken. So if you don't notice, it's fine. And the other thing is that I literally work on a tool that QA engineers use to write tests. So I obviously run into a lot of edge cases. Don't make this talk depress you. All right, so let's talk about events. I work on automation, which means I need to literally listen to all the stuff users do and record it. And like you type stuff on the device, and instead of like writing tests, you record them. So with a show of hands, who here has end-to-end tests, real end-to-end tests in their system? All right, so I see about a third or maybe a fourth. You are better than JavaScript Israel. I asked this like a few days ago, and 85% don't have more than 30% coverage in their end-to-end tests. And that makes me sad, because it means we get bugs. And then we asked people, like, who here is happy with their end-to-end tests? Like, thinks they're fast enough and good enough and stable enough. Right, so there is like two people. I want to talk to both of you after the talk, because like you're my unicorns. Most people are not happy with the way their end-to-end tasks work, and I want to figure out why. And this makes me sad. So why is this hard, right? Basically, we have these tools that let us like fire events. The DOM has an event model which we'll cover, and testing should be easy. In React, if I want to, for example, add a click, right? We are all React developers here. If we do have a component, we just add an on-click to that component, and then we just add a function, and that function executes whenever the user clicks on the element, and this is good. React is good. And we think that what React is doing here is adding a click handler. But to figure out what React is really doing, we have to take a step back. So the way the web works is specified in something called the DOM specification. The DOM specification is written by a bunch of people called WhatWG. It used to be a bunch of other people called W3C, then there was some drama. Now it's WhatWG, which is, by the way, another thing you can get involved in, is actively looking for people to help. And they expose this interface called event target. Everything you can add events to in the browser is an event target. So like an XHR, like an XMHTP request is an event target, and elements are event targets. And event targets are really nice. You can add event listener, remove event listener, and then actually fire events. And the reason this is nice is because it's a pretty simple like interface. It's pretty simple, and it's pretty similar to what Node does with event emitter. You just add events, remove events, and fire events. And you can do this today. You can add event listener for a click, then dispatch a mouse event of a click, and that will test your user flow. Now, this is, you don't have to read this, it's a long text, but it's literally how the DOM specification specifies event target. And it's a bit long, but it's not very long. And it's really clear. And the takeaway I want to give you about the specification is that it's actually quite readable. Like, if you want to figure out how CSS works, because CSS is confusing to me, you can just open the CSS specification and read it. And it's a lot clearer than MDN or W3 Schools or any of those resources for me, because it's really surprising, because you'd expect it to be written in like this very formal way, but they have a ton of notes that explain why things are the way they are. And the WhatWG spec of how HTML and the browsers work literally starts by defining events and event target. Now, events on the browsers have 3 stages. When you add a click listener, you are not actually just adding a click listener to the element. First, events go from the top to the bottom. This happens when you do add event listener with a third parameter called the capture flag. You can tell an event listener, I want to get this event first. Then the event goes on the target element, and then it will bubble up. This is also called event bubbling. So if I add an event listener on the body, like let's say I have 3 event listeners, 2 on the body, 1 with bubbling and 1 with capture, and 1 event listener on the button, the body will get the event first with the capture, then the element will get the event, and finally the body will get the event again with bubbling. So, and this is, by the way, the same way in every UI model ever. So Android does this, and iOS does this, and literally every model has a way to intercept events before and after. The web does it very automatically compared to other platforms. And events targets are like this. So why is this useful? Why do we actually need a model that does capture and bubbling, and who is using it? So, and at each phase, by the way, you can call stop propagation, and that will stop it. So I can, for example, be super annoying, add a click handler on the body, stop propagation on click events, and like nothing happens on the page. That's like pointer events none for clicks. Don't do this. It's especially harmful for accessibility, by the way. Right, so capture pretty much is useful when we want to catch stuff first, which makes sense. So let's say I have a model dialog, and the model dialog needs to react to a click on the outside of the model. One way is to do like a high-order component that adds an overlay with zero visibility, like visibility hidden, and then catch a click there and use like maybe a portal with React. And then you can just add event listener on the body with capture and intercept it in your element, which is a way simpler in my opinion. So whenever you need to do like outside click behavior, or needing to intercept something like an aspect from outside the element, consider capture. It's super useful. Bubbling is a ton more popular, right? So capture is really useful if you need to enforce behavior from the outside. If you're an extension, if you're using a third-party component, if you need to do clever behavior. Bubbling is super useful because it lets you do exactly the reverse. And bubbling lets us do a pattern called event delegation. Who here wrote code in the JQuery days of event delegation? And all right, so some of you, more than I suspected. Bubbling lets us move events up, which is really useful because it means we can add an event listener once, on like the HTML, for example, and catch all the events and react to them. So in the jQuery days, and there is like a native example just for closure here, you would do like a body dot on click span, and you would catch all the clicks on all the spans on the page. And the way it works is they add an event listener, they check if the event target, which exists on every interaction event, is a span, and if it is, they react to it. And this lets us attach one event handler and not many event handlers to the DOM, which turns out is really useful. And it's so useful that this is exactly what React does. So React has this architecture called event plugins. It's like in the React DOM package under events, simple event plugin, or mouse enter leave event plugin, all the event plugins are there. And basically what it does, it adds a click handler on the root you mount the element to. And then there is like a huge switch case, because for some reason we love huge switch cases, that normalizes it across browsers, and it dispatches it to the components. So, and actually, you can do in React on-click capture, which does the other thing. It adds like a capture handler, and it will do capture order instead of bubbling order. And the way events work in React, React does not add an event listener when you do an on-click. The first time you do an on-click, it adds one event listener for the whole thing, which is really confusing because, for example, Chrome has dev tools that like you can go there and they will show you what event listeners you have. And if you open the Chrome DevTools and look at the get event listeners or monitor events or any of those methods for debugging events, React won't show you the correct events. It will show you just one event listener on the mount root, which is fine, but I think it's a bit confusing. So why is this confusing? So let's say you're writing automation, which is what almost no one is, at least in this room and in the poll. And you have an element that has an on-mouse enter. And this is like the legit code from the React DOM source. So when you do on-mouse enter, at least my expectation is for React to listen to a mouse enter event, which it does not do. Like in no place React will listen to a mouse enter event. What it will actually do, it will listen to mouse out and mouse over, and it will calculate when a mouse enter happened based on those two events. And that's with browser normalization. When you do a click, React might listen to a click, but it might listen to a mouse down and a mouse up and look for the delay in order to normalize browsers. So when you listen to an event in React, there is a synthetic event layer that will normalize events across browsers, which is super useful from the white box perspective. As an app developer, it means I have less bugs on when testing my app on Internet Explorer or Safari. But as a tester, it means I can't rely on dispatching the correct event in terms of React doing the right thing, right? Because I added the mouse enter handler, but if I fire mouse enter, nothing is listening to that, and I have no way to know. And React might change it in a minor or in a patch version, or I don't know, do a security release because for some reason on mouse out is not good for some reason, or like Safari does a new version, and I can't rely on React firing the right events. And React, in the whole React Fire discussion, those of you who follow that, they talked a lot about removing static events and dropping support for old browsers. And they ended up just comparing the evergreen browsers like Firefox and Chrome and Safari. And those browsers are still quite different in the way they do events. And like there is a sad post by Dan Abramov where he says, we tried, it doesn't look like we're going to remove the static event system. It's too complicated, there's too much stuff going on. Which might be good for us. But we still have automation tools that need to do certain things for automation. And Chrome needs to know how to dispatch clicks, right? If I literally click on a screen, Chrome needs to figure out what I clicked on. And then if I do a click in Puppeteer or Selenium, Chrome needs to know where the click happened. So Chrome has this like debugger protocol, which is what it uses to debug JavaScript, but it also uses it to debug all the other shit. And that does that's like a WebSocket protocol that has superpowers. So, for example, the Chrome DevTools is a Chrome extension that opens a WebSocket into the C++ stuff in Chrome, into like the process, and that can dispatch commands like hover on this element, click on this element. And when I opened this, I didn't look at the clicks because clicks are a pretty complicated event if you think about it. And in most cases, you can dispatch an event, and that just translates to a literal JavaScript dispatch event, which kind of sucks because it means it's hard to write automation. But clicks are special. So an input.dispatch mouse event is how like literally every automation tool clicks. It's how TestCafe clicks, it's how Selenium clicks through Chrome driver, and it's how Puppeteer clicks. So Chrome has this crazy internal architecture where it dispatches the mouse event. It does a really complicated calculation based on the compositor and where the frames and the zoom are. It accounts to really compatibility-related stuff like touch and mouse events. It handles multi-monitor and a bunch of other calculations. And it's actually like quite an interesting algorithm. If you ever need to write a tool that calculates where something is on the screen, probably follow that code path. I tried to get it to run on WebAssembly and I couldn't, but it's like work in progress. And then that's the disappointing part. It ends up just doing a CG post mouse event, which is an internal Mac API that only runs on macOS. And there is actually a separate file for injecting mouse events for Mac, Windows, Linux, and other architectures for dispatching mouse events in Chrome. So if I write like automation and I test it on Mac, the code that actually runs on Linux or Windows later is different. And like if I end up having to test, for example, multi-monitor, it probably won't work, which is a trade-off. Some events are dispatched through like regular event dispatch. Dispatch event is like the regular dispatch event in JavaScript, just in C++. But a lot of events go through CG post mouse event, which means that browsers are different. Like even in Chrome, different versions of Chrome are a bit different. Versions of Chrome running on different versions of macOS are different. Versions of Chrome running different versions of Windows are different from each other. Just like even if just the build moved, and it's not 100% the same code when doing real clicks and simulated clicks. So even if you do like when Chrome dispatches a click, it has like specific timing that doesn't actually simulate the way clicks work. It's actually like a bit of how reCAPTCHA works, the way they detect bots, and it makes it really hard to write good testing because you don't get the same events. The same events don't fire as the listeners you add in React. And then when you use native events, which is like the debugger API, that's different between every operating system and every version. So it's a bit depressing. I never said this is a happy talk. And it's I really want to work on open source to help fix this because it makes writing automation hard. We have this trade-off whether we want to A, dispatch events, which is flaky because React might change the event plugin architecture. B, fire native events or use Selenium Puppeteer, which will be a bit different between Mac and Windows, and it's actually things I ran into. Right. So what do we do at testing? We basically connect with the debugger protocol and do input.dispatch mouse event, which I said before isn't great. But between the two alternatives, it's probably the better one. And the reasonable part, like the cool part is that I can actually go through the Chrome code, which I promise is really not scary. Like compiling the Chrome code is not fun, but there is a website called CodeSearch, cs.chromium.org. You can just type random stuff into it, and it will show you the Chrome source for that stuff. And their C++ is decent. I probably shouldn't say the C++ is decent on camera. Never mind. We basically have a ton of code that deals with the edge cases of dispatch mouse event, which isn't great, I guess, but it's the thing that works. So if you're writing automation and you're doing Puppeteer, for example, or Test Cafe or Selenium, in Selenium you don't have control because Selenium is like an HTTP server that connects to the socket. But if you're doing Puppeteer, for example, consider normalizing this. Consider like checking your tests across different versions of Mac and Windows and making sure that your tests are stable across different versions. Because it's a big issue, from what we saw. Right, so what have you learned? We have input.dispatch mouse event, which uses OS level stuff to simulate user events, which is cool. We heard that Chrome has to account for a ton of stuff, like frames, elements, zoom, multi-monitor, and other considerations. That in turn causes a ton of events. So like I didn't actually speak about it because I don't have a lot of time, but click is just one of them. If you dispatch a mouse event or do an actual click, Chrome will fire like 40 events. It has pointer events and enter events and leave events and DOM activate. Who here ever heard of DOM activate? Yay, no one, I'm happy. All right, we learned that events capture, reach the element, and then they bubble. And we learned that React intercepts the events through event delegation on the React route, which means tools that look at event listeners won't work for React. And then it dispatches the event on your element. And when I started working on this talk, I was about to, like, it was supposed to be like a very happy talk of, yay, we're going to get rid of synthetic events, but we're not. So just be careful when doing automation. All right, so takeaways. Frameworks do weird things sometimes. Angular or Vue are not better in this. Abstraction is leak. So when React tries to have your back in one area, which is normalizing mouse events, so you write cleaner code across browsers, it will break other stuff, which is fair. Knowing the platform, like knowing how DOM events work, is worth your time because you can do cool stuff you might not be aware of. The web spec is not that scary. Like, I encourage you, if you have one takeaway from this talk, it's not event delegation, it's not testing, it's not like automation is hard. It's like open the WG HTML specification and read one paragraph. That's easy, that's like, you can totally do it. And I promise you that a lot of people think it's very unreadable, but a lot of it is very readable. Some of it is not, but most of it is. And automation is hard and requires a lot of normalization. If anyone wants to get into open source, and in particular into Node.js, we are looking for collaborators. And then also we are hiring a test team, but like everyone is hiring. So if you want to work with me and think it's cool, like talk to me. And if you have good stories of like how you did automation well and what worked, I definitely want you to shoot me an email because we're looking for those. Like everyone is talking about doing automation, and a lot of people are just not doing it. So if you want to do open source, feel free to hit me up, and I will also be available in the conference. And feel free to talk to me. Great, thank you.